I'd like to introduce myself. My name is Kola Temple. I teach at Future Horizons. Basically, I teach mathematics and physics.
Next.
My name is Yadiza as well. I am a teacher for chemistry and also biology.
Yes, good afternoon. My name is Tasaleo Ganamaleo. I'm the English teacher at Future Horizons Academy.
My name is Jit Maidit. I'm a teacher of commerce and accounting in the School of Arizona.
Thank you. My name is Mading Chol. I'm teaching history and geography in Future Horizon Academy. Thank you.
Thank you so much. Good morning, all of you. My name is Mr. Quidlord, the principal for Future Horizon and a teacher for geography and ICT. Thank you.
Okay, you can call me Tonton. I'm the one handling now agriculture, biology, and I double as a technical support with the school. Thank you.
Next, the student, please introduce yourself, your name, and the class.
Future Horizon Senior 1.
Good. Next.
Student.
So I'm by the name Wise. I'm a student in Future Horizon.
My name is Samantha. Future.
Yes, be audible.
Yes, say again.
Come, be
My
calm.
name is Salah Ejer from Future Horizon Secondary School, a woman student.
My name is Mukundulu. I'm a Future Horizon Academy.
My name is Afes Ndulu. I'm a student in Future Horizon.
My name is Abdullah Trembon. I'm in Senior 1. Future Horizon is 1.
Lead us in starting the other step.
Okay, so I think I'll be moving around. So what we have done here, this is a laboratory. This is a school lab. And what we showing to the students is the potentials of building a science-based curriculum supported at the Future Horizon. So this is a lab sitting arrangement, and we have different lab items here. So we want to pass through what we have here. We'll demonstrate and show to the student. So I will give to Yar to start with chemistry and then biology. So she will be moving around. I want you, the student, to pay my attention. Science can never be learned without practical. So this is for practical. You will see live, you will see what we are talking about by seeing it. Okay? So Yar, you can take over and then you can tell briefly what we have in chemistry, biology.
Thank you so much. I'll be explaining to you the different elements that we have here in the chemistry, for the chemistry department. So first of all, I'll start with giving you the names of the equipment we have. This is called a glass beaker. Mainly it's used to carry chemicals like sulfuric acid, the ones which normally react with plastic surfaces. We put them in the glass beakers. And then also we can use it to carry water. This, we call it the conical flask. We use it for the titration and other experiments. This is our red litmus paper. We use it to test the acidity or alkalinity of a substance. You either can use either a red litmus paper or a blue litmus paper. This is called a pipette. It's mostly used to draw out substance. For example, I can use a pipette to use it to draw out some water, just like this, how I'm going to demonstrate. So normally there is a line that is shown on the pipette here that you have to observe. This is a pipette of 25 milliliters. So depending on the substance that you are pipetting, it must not exceed the line and it should not be lower, so that the quantity is exact for the experiment that you're conducting. So if you want to release the substance, you just remove your hand from the top like this, and the substance will fall back, just like the way you can see the water is pouring back into the glass beaker. So this is this is a burette. The burette is used to, normally the burette, let me say for example for this setting, this is for a volumetric analysis, so we can use it for titration. So the substance that you are going to titrate, you pipette it and put it inside the conical flask. Then the other substance that is going to be put here is a substance that will be mixed with this. So you pour the substance from on top here. Of course you have to use your funnel so that the substance doesn't pour down. So you will put the funnel on top here, and then you pour the substance inside. After pouring, we shall have a clamp here that will help us to hold so that the substance that you pour here does not pour out direct. You can control its flow and the quantity that is needed, while you observe the reaction from down here, so that when the color you are expecting comes, you will stop removing this chemical substance that is up here. Then this is a measuring cylinder. The measuring cylinder is mainly used to measure the volume of the different chemicals that you're using. For example, we can use water. They can ask you to measure the 25 milliliters of water, and you'll use this measuring cylinder, but you can also use the plastic measuring cylinder as well. Then we have our thermometer, which is mostly used in rigorous titrations, which involves temperature changes. So you may be asked to measure the temperature of the substance. If, for instance, the temperature of the water that you're supposed to use is 50 degrees Celsius, you can use this thermometer to make sure that the degree of the water you're using is not above 50 and is also not less than 50, just exactly 50 degrees. And this is mostly used to steer the substances that you are using. For example, if you're mixing two chemicals at the same time and you have to dissolve it in water, if for faster dissolution of the substance, you just mix it with this. And we have this, which is called the stop clock. It's mostly used to time the range between the color changes between the substances that you're adding. And then this is mostly used to mix up substances. It also has, this is a volumetric flask. So the volumetric flask also has a mark, which is just above here. You have to observe it keenly. You will be asked to measure a specified volume. You can pour a chemical inside. Then to dilute, this is mostly used to dilute chemicals. So to dilute that chemical, you will have to add some water. So the amount of water you're going to add must not exceed the mark that you'll be seeing on the volumetric flask. So after adding the water, then you will just shake it so that the solution mixes thoroughly. Then
You open it for half the space.
This is called a boiling tube, or you can also call it a test tube, but the best name for it is a boiling tube. It's mostly used to boil substances. You can use it to heat powder chemicals. For example, when the experiment is requiring you to heat a substance, you can put it inside here. It's the best test tube that is used for boiling. Or when you're asked to boil a solution, you can also use this same one. Then we have these smaller test tubes. These are the ones we use to observe the changes. For example, when you are asked to observe what happens when you add sodium hydroxide into a solution, you put the solution, and when you're dropping, you use this test tube. It's the best test tube which is recommended. So what we have here is, this is our gas cylinder, and then this is our Bunsen burner. There is supposed to be a tube that connects the Bunsen burner to the source of the source of the gas, but apparently right now it's not yet being connected. Yeah, it.
Bottom of the Bunsen burner. Put it here.
So as the Bunsen burner is being connected, the heat surface is going to be from here. So whatever substance that you're boiling, for example, if you have this flat bottom flask that you can use to boil, you're asked to boil a chemical, you will put it on top here. As the heat is being released, you will leave it to boil for the specified amount of time that you're asked. Then after the substance boils, you will put it down. This is called a cock bearer. This cock bearer is mostly used for experiments. For example, if you're asked to use an experiment or to find out what happens or what causes rusting. When rusting is to happen, that means no oxygen should be there. So this cock bearer does not make oxygen pass through. So when you cover a substance with a cock bearer like this, there is no oxygen inside this substance. So it's mostly used to cover our substances. And then this is called, this experiment is used mostly to separate substances. For example, a mixture of water and cooking oil. You want to remain with either water only or cooking oil only. When you mix it, you will pour it inside the separating funnel, and when you pour it inside the separating funnel, you release the substance that is going to be below first. Of course, it's the water that will be below. So, using your beaker, you use the beaker to collect the water that will be released from the separating funnel here. So, after pouring the substance, you will open slowly so that it pours slowly, like it pours at a slow speed, such as the water is separated from the cooking oil. And then this that is holding it is what we call the retort stand. I think I have talked about all the substances. So now here we have our different chemicals that we shall use to make solutions, and then the different chemicals that we shall also heat. This is iron metal. This iron metal. This is lead nitrate. This is potassium permanganate. This is ammonium ferrous sulfate. This is cupric sulfate, or you can call it copper 2 sulfate. This is calcium chloride. This is sodium hydroxide pellets. And then this is called a suction pump. This is also the iron metal, still the same solution. This is sodium metal. What we have here is called the iodine crystals. This is potassium iodide. And then this is the box that contains our red litmus paper. And this is the one that contains the blue litmus paper. This is our masking tape. It's mostly used just for labeling of the test tubes and the elements. Then this is mostly used to mix our substances. Then we have what we call the round bottom flask, which is used also, which can also be used for mixing substances. We also have our whisking tube, which is here, and then this is our capillary tube. So those are the different elements that we have and the apparatus that we use for chemistry experiments. So this apparatus can be used at different intervals. Some of them all together, but some of them at different intervals. Now, that was for chemistry. So this side now we're talking about the apparatus for biology. So as you can see what we have here, we have our light microscope, which we can use to observe microscopic organisms. We have our magnifying glass, which we can also use to observe small organisms or to magnify a substance. What we have here is called the forceps. These forceps are mostly used when you are dissecting a rat, a cockroach, or a toad. Then this is what we call the spatula. A spatula is what we use to scoop the chemicals from their tins and put them in a different plate or container for mixing. This is a mortar and a pestle. We use it for grinding, most especially when we are making solutions, like when we are making a starch solution from a fruit or from a food substance. We can use the mortar and pestle to grind them. We add some water to make the solution. Then we have our gauze. This is mostly used when you're dissecting an animal, and then by mistake you cut a blood vessel. So when you cut a blood vessel, that animal is bound to bleed. So to clean up the blood, because you do not need the blood to mess up the organs that you're supposed to observe, you will use the gauze. Then we have our droppers. These ones are mostly used to remove chemicals. I can show you how it works. So when you have, this is now our chemical that we have been asked to use. So they can ask you to use 3 drops of that chemical. So when they ask you to use 3 drops, then you have to specifically use 3 drops. So you just put it inside, you squeeze, then now you add the 3 drops, 1, 2, 3. Just like that. This is how you use your dropper. Then after you add in the dropper, you follow the instructions of what the experiment is requiring you to do next. These are called the dissection pins. They are mostly used to stick out the skin of the animal that you're dissecting. For instance, if you're dissecting a rat, after removing the skin layer, you will spread it out and then you stick it using your dissection pin. And when you're asked to observe other parts, you will also use this same dissection pin to stick it out. Then we have our slide glasses, but for this case I have put the slide glass just below the microscope here, because the organism that you're going to observe, you're going to put it on your slide glass. You put the substance on the slide glass. After putting it on the slide glass, then now you're going to put it under the microscope where you can observe. If, for example, you are asked to observe the chemical cells or the particles of an onion pellet, then you will need this, because when you spread it, you will not need it to move. So you will just put this above your slide glass. Then now, depending on the magnification you've been asked to use, because there is medium power, low power, and high power. So you will, if you want to change, okay. So if you want to change the power of the magnification that you're supposed to use, you can just turn it around like this. You can just turn it around. So for this is for the high power. When you're asked to use high power of magnification, you will use this. When you're asked to use medium, you use this, and then you're asked to use low power, you use this. So this is our adjusting knob. We use it to adjust the length of the body of the microscope. So when you want it to be lower, when you want to lower it a bit, you do it like this, and when you want to raise it up a bit. So when you are observing using your light microscope, this mirror down here has to be put in a place that can reflect light, because it is through the light reflected from the mirror here that you're able to observe the organism which is on the slide. So now as you're observing, you just put your eyes above the eyepiece and then you observe until you can see the object clearly, until you can see clearly what you're asked to observe according to the question that you've been given. When it's clearly seen, then now you will go and record your readings from what you have done. This is our syringe. The syringe is mainly you use it. Sometimes it can be used to extract liquid components from inside the body of the animal you're dissecting. Sometimes you can use the syringe to extract the chemicals that you're supposed to use, or sometimes they can ask you to wash the inner intestines of the animal that you've been given. So you use this syringe to pull out to draw the water from the test tube and then insert it inside that animal so that it's washed. And then you will also use this syringe to remove that water that you've added inside there. And then mainly this piece of cloth is used for cleaning the microscope, because for its efficient functioning, it has to remain always clean. So this piece of cloth, we use it for cleaning our microscope. So that is all I can say about the biology apparatus and the chemistry apparatus. Thank you.
Professor Katekova to explain physics apparatus.
Thank you. I will start with what we have here. Some of you know very well what we call magnets. We have different types of magnets. The one is the blue chip. It is this, and this is the bar. These are magnets. And we normally store them with a wooden in between to avoid attraction most of the time. So these are magnets, and this is also a magnet. And you can see if a magnet is hard to separate them. No?
Close the door. The door.
Close the door. If I put a negative and a positive, they are fusing. Actually, it will be moving away. And if it doesn't, it will flip itself. It will have to turn. So it's moving away. It's refusing. Because it's negative and negative. But the moment I change this other side, take it. Take it. These are magnets, and you have more. These are metallic plate. You've heard about copper, yeah, zinc, iron. These are metallic plates. So you learn some of them. These are called metallic plates. These are lead mirror. These are mirror. This mirror is a concave mirror. And we are going to see the way eye work and how light is travel. You use mirror to reflect to see how light can move. So concave, this is convex, and this is concave, and then the normal mirror, the one for you can see your eyes. So these are lenses, and some of them are here. And you see how light works. You know? Light travels through, and it's be reflected. You normally see ourselves as mirror, isn't it? But we'll see two types of mirror: convex mirror and concave. And we'll learn more. And this device is for, we have been talking about measuring weight, yeah? Masses, weight, and masses. So we can use this to measure the mass of a given item. So this is a weighing scale. And then we put something on top here. We want to measure it to show the reading here. Very small, microscopic. We want to measure 1 gram. You can put something small on top here, and then it will do the reading. It's automatic, and you can charge it. It comes with a charger, and it has a battery. So this is for weighing, not the mass. I know most of you are used to the big weighing machine where you can. So this is for measuring small. This is for showing the amount of electricity flowing. And you have seen the wire, electric wire. This is wire basically for connection, physics. So these are for physics. This one is, you've heard about pendulum. So we'll use the string. This is the string. Threads, normal threads. So we hang it somewhere, and then we swing it. Pendulum. So it will be moving around till it will stop. Of course, we'll use a timer there to time how long it will take around to finish oscillating. So this is pendulum. We can also measure masses. You remember we measure weight using the Newton. So this is a spring button. You will hang it somewhere here, at non-movable place, and then you hang something here. And normally you see somebody in the market there, they're similar one like this. One for measuring kilo of meat, you know, one for measuring sugar, like this, basically measuring masses. But you know the relation between mass and the weight. So this is for measuring the spring measure. Again, we have this. This is rosters. This is rosters is basically the amount of electricity passing through here. We use this as like a brain of center of locomotive activity, where something may be moving. You know, it acts like a small engine. So we'll use this. Here we have this. This one is for measurement. We call it Vernier clipper, and the Vernier clipper is this. Yeah, we call it. This is the Vernier clipper. Let me just. Oh, this is the Vernier clipper actually. This is Vernier clipper, but this is micrometer. This is a Vernier clipper. It is basically used for measuring small items. Here you can untie it, and you can roll around here. Something small, micrometer thing. You put it in here, and then you seal it. You seal the measurement, and you will do the reading here on the scale. So you can rotate it till it comes to the end. But once you rotate it to the end, the gap here will keep opening. The gap in between here keep opening. So you put something to measure here, microscopic. I know you're used to tape measure. It's for measuring big things, you know. But small thing, millimeter, how do you measure them? You use this for measuring them. The same thing with the Vernier clipper is also for measurement. You rotate it, and you see the edge here is expanding. So whatever small thing you need to measure, you put it in between here, and then you seal it again. And then you do the reading here. They are reading scale, so you do that. These are marbles, small one, and they are magnetic in nature. These are steel metallic steel. So we use the magnet is to definitely pick them. So we use them for showing. And this is a small copper for connection. These are marbles. We use them. Yeah, and we use them a lot. We try to measure them. We try to play around a lot of experiments. So these are basically physics equipment. The apparatus for physics, for chemistry, for biology. So basically, we have taken care of all the science.
All sciences.
The next move now will be agriculture. You know, we have to bring in the tools as well. So I think
for 2 minutes, Yara has to take them through the reproductive.
Yes.
For 5 minutes for familiarization.
Exactly.
So kindly follow us. Yeah.
So this chart, it represents, the male reproductive system. So this chart is mostly going to be used when they have reached the topic of reproduction. So these are the male reproductive organs, which are divided in their different views. The posterior view of the male reproductive organ is here, and this is the anterior view. Then when you want to, or when you're talking about the testes, this is the diagram. Then the cross-section of the penis is here. The spermatogenesis, this is the process by which the sperms are being formed. The process is called spermatogenesis. So this is the diagram describing how it happens. Then the prostrate, which is just below the testes, is here. Then the perineum. And this chart mainly just shows us how the male reproductive organ works, how the sperms are formed, and how they move from one place to another, and how the male gender is able to excrete. This is for the male reproductive system. Then we also have the chart for the female reproductive system, which is here. And we have the structure of the breast, the anterior view, and then the surgical section of the breast. Then we have the ovum, or you can call it the ova. When it's a single egg, you call it the ova. Then when they're mating, you call it the ovum. So the ova, this is the egg that is being fertilized by the sperm. Then this is the diagram of the menstrual cycle of how the human body or the female gender is able to control the process of their menstruation. We have the ovarian, we have the days which are starting from 0 up to 28. So we have the menstrual phase, which is for 4 days here. This is the period in between which the menstruation takes place. Then we have the proliferative phase, where the uterine walls is being repaired after it has been degenerated for the menstruation to happen. Then we have the secretory phase, which takes place between from the 14th to the 26th day. This is the phase where the hormones which are used or which stimulate menstruation to happen is secreted. Then we have the premenstrual phase, as the uterine walls is being repaired, and then it again starts to degenerate for the next menstruation to happen. Then we have the ovary, fallopian tube, uterus, and the vagina. So this is the diagram, and this is where the eggs are secreted. The egg is, or the ova is secreted in the fallopian tube as it makes its way to the uterus through the fallopian tube. So it makes its way to the uterus. When it reaches the uterus here and it's not being fertilized within 3 days, that's when the egg now secretes the hormone which makes it to degenerate itself, and then that same hormone is going to help to degenerate the walls, the uterus walls. So the uterus walls which degenerates is the one that passes out as blood during the menstrual cycle. So this is for the female reproductive system. Then we have the diagram showing the respiratory system. So we have the diagram for the respiratory system. So in this diagram, it is showing us how we are able to breathe in air and breathe out. So it is also showing us the sites where the gaseous exchange takes place. So as we all know, the human body breathes in oxygen and then it releases out carbon dioxide. So this is for the entire respiratory system. But then when you come here, it's just showing, this is showing inhalation. So as you can see, we have the neck muscles, the external intercostal muscles. So according to this diagram, it is showing how one is able to inhale. So when you inhale, there is a way your ribs contract. Then when you exhale, they relax. So as you can see, according to these diagrams, the rib cage is starting to contract because the person is inhaling air. And then this is the diagram that is showing us how the chest or the ribs, how the movements in the chest takes place as a person is breathing. Then we have our larynx here, then the size of the gaseous exchange which takes place in the alveoli, whereby when the air enters, when you breathe in the air, the oxygen which is needed diffuses within blood, and the carbon dioxide which is not needed diffuses outside, and then all this process happens in the alveoli. So the carbon dioxide that diffuses out is normally exhaled outside. So this is showing the gaseous exchange in the lungs, and then this is now showing us the diagram of these small branches that you see here. We call them
bronchi.
Yes?
Bronchi.
Yeah, these are called the bronchi. So these bronchi are the ones that have the alveoli inside, which helps for the exchange of gases in and out of the human body. So that is about the respiratory system. So when we move the other side, we have the skeletal system here. So as you can see in this diagram, the body is made of bones, and those bones are the ones which we call them the skeleton. So we have the bones, which from this diagram shows us the bones that we have from the head up to the toe. So we have the rib cage here. We have the bones of the skull, which protects because the skull is the one that protects the brain. So we have the bones of the skull here. Then we have the bones of the hand and foot, which are here. We have the structure of the bones. These are mainly found. For example, this one is showing the one we have at our joints. Then we have the ones these are now the different types of joints that we have. The movable joints, for example. So we can be able to move the bones which are here, like the ones at the knee joints down here we can move. These are the movable joints. Then we also have other joints which are slightly movable. Those ones now we are talking about the ones down the feet here because you can slightly move them. And then now we have the structure of the spine, which you can also call the vertebral column, which is just behind our back. So this is for the skeletal system. Now when we move to the next chart here, which shows the digestive system. So this chart shows us how the body is able to digest the food that we eat, that we take inside our body. So as you can see, digestion normally is depending on the substance you've eaten. For example, for starch, its digestion starts from the mouth. As you put the food and you chew, that's now the process of digestion which has started. So as it continues, we have the stomach, which secretes some chemicals, for example, hydrochloric acid that helps to kill germs which have escaped together with the food. So this is the diagram of the stomach, and there are some food particles that are digested in the stomach. We have the intestinal villi, which also has specific hormones that it excretes to help the process of digestion. We have the liver that also secretes some hormones. For example, it secretes the bile juice that helps in digestion. We have the teeth. We have the salivary glands, which secretes the enzyme salivary amylase used for the digestion of starch. Then we have the colon, which is also known as the large intestine, which also helps in digestion. We have the rectum and the anus. The rectum is where the feces or the waste is being stored in the body. Then the waste normally is secreted out through the anus. So this is the diagram of the rectus and the anus. So this diagram is now, together when you follow these arrows, is helping to show us the digestion process, how it takes place, right from the esophagus as the food enters the stomach, as it moves to the large intestine, small intestine, and then to the rectum and down to the anus. And these are the organs. This diagram is showing us the organs which are involved in the process of digestion. Then now to the last chart here, which shows us, this chart is now for chemistry, not for biology. This shows us the periodic table. So with this chart, a student is able to see the elements and identify their atomic number. They're able to identify the symbol of that element, and then they're able to see its mass number, the mass number of that element. So mainly for this level, they use the students study the first 20 elements of the periodic table. So using this chart, the students are able to see the elements that they need to, they are required to use, and the symbols plus the mass number and the atomic number. So this is the chart for chemistry, and that marks the brief introduction of the different charts that we have. Thank you
so much. How about Thank you so much once again, Jack and Professor Temple. Dear teachers, I thank you all for the participation. Our great students, thank you for attending today's lesson. We were actually introducing to you the lab and its apparatus, which are being used according to subject. So we classified them subject by subject. You have seen when Teacher Yan was explaining. The first explanation was about chemistry. Then the second one was biology. Then Professor Atem took over from her and explained the apparatus for physics. This is all we want you to learn. I believe they are not new to you, only that you might have not seen them physically before. But you know them and you know the pictures. When you are given an assignment in the class, you could answer and you know each. Now we have brought it closer to you, and this is part of our strategy of saying that we have what is called STEM education in Future Horizon Academy. So S is science or scientific. Then T is technology. Then E is engineering or economics. Then M is mathematics. When you couple them all, they bring what is called STEM strategy. We could be the second institution to bring this to the students at a doorstep, because the University of Juba is having a STEM center. And that has been the only center in the country, if I'm not wrong. I believe this one will help. It is not brought for our schools only. Other schools who are interested and would like to come and carry out the experiments can come and schedule or schedule with us. And they can be given days. One school, 1 day. Or if there are too many, maybe 3 schools per day. We can be giving a school 1 hour or 2 hours. Then another school take over from there. So this equipment will be used purposely for the experiments. And they are for the whole nation, and they are for the Ministry of General Education, and we provided them. We thank Professor Atembul Malam once again as the Director of Future Horizon Academy for having thought about such things. Many things were missing in our country, but he did not think about establishing a hotel. Instead, he said he wanted to further the experimental learning in academy. My name remains Mr. Kwirgwat, the Principal of Future Horizon Academy. I would like to ask you kindly to go out and we take a final photo, the group photo.
So this was a class we did before, basically about finding volume and surface area for given kind of shape. This is the cylinder, find the area of the cylinder, we've done it before. And if you open the cylinder, it looks like a complete roll up thing. So if you open this cylinder by cutting it here, and you open it, definitely it will look like this. And if you fold it again, this part will be now the part of the circumference of this. So this will be 2 pi r, and this is length. And the area here will be 2 pi RL. Isn't it? That's what we did before.
Yeah.
And we say the volume is this circular part times the length. And how do you get the circular part? This circular part, area of a circle. Pi R squared. That is area of the circle times the length. This is the volume. So we did this before like this. And we say this is a sphere. Surface area of a sphere is pi rho R squared. And the volume is 4/3 rho R cubed. You know the earth is not circular. A sphere is something that looks exactly like the globe. It means these are not the same. From here to here is not the same from here to here. So we can call this a rho, we can call this an arc, and you get the volume and the surface area. And the other ones which you have here was a pyramid. And when you split a pyramid, it looks like this. So to find the surface area, what do? When you split it, you will see this is a circular triangle. So you find this area, and find this area, find that area, or one of the areas, then times what? And the number here, there are 4, plus the area of this now. So this was about getting that. And the volume will be third. Base area times now the height. So that is the formula we've written there.
And the board is electronic board.
Yes, this is a digital board. Because we are using a digital pen, and you can be able to commute and change the board as you want it. You create more space. So this makes our learning efficient and effective. You can demonstrate pictures, pictorial things, and you can change the background of the board to white boards, and you can use the flag by changing. You change the font size so that at least it looks bigger. So this is the digital system we are using, and it's able to do wonderful in our teaching.
Thank you, Professor. Thank you, teachers. Thank you, dear students. We have come to the end of the introduction of the laboratory apparatus or equipment. If there is anything you would like to know or you want to ask a question, you are free. You can raise your hand and ask what you have not understood throughout the process from the lab up to the class. Do we have any question there? Everything is clear?
Yes.
Thank you so much.